CAP theorem is formulated by Eric Brewer, states that in a distributed database system, you can only achieve 2 out of 3 guarantees at any point in time. C stands for consistency, A availability, and P partition tolerance. So what is consistency? Every read receives the most recent write or an error. If I would explain this to a 10-year-old, for example, imagine a society with a water connections to every house in the society. So consistency is something like everyone gets the same water quality. If you turn on the tap, you should always get fresh, clean water at all times. If there is an issue, you would rather wait until the water is clean and fresh rather than getting dirty water. So that is consistency. Availability. So availability, every request, read or write, gets a response even if failures occur. If we come to our example of the society with the water example, right? Water always flows no matter what. So that's availability, right? Even if the water quality isn't perfect, you can always get some water. The system never says, sorry, no water for you right now. So either dirty water or clean water, some or the other water you always get. So availability will be 100%. Coming to partition tolerance, the system continues to function even if network partitions occur. Some nodes cannot communicate. If we come to the same example that we are talking about, the system still works even with broken pipes. So even if some pipes are broken, that's like some network failure happened in this water system, it still keeps working it as best as it can, right? Some houses might get different water pressure or quality, but water still flows. That's a partition tolerance, right? Since network partitions are unavoidable in distributed systems, you must choose always between consistency and availability in case of a failure. You can see the diagram here, the overlaps and the databases that you can use for each of these. We will discuss in detail. CP, that's consistency plus partition tolerance, but not availability. For example, you can use MongoDB. The scenario could be a banking system, right? Banking system ensuring all nodes always have the same latest transaction details. That's consistency. If a network partition occurs, then system may reject some requests, reducing availability rather than serving potentially outdated. So I always wanted to see my updated bank account status rather than, even if it is down, I'm okay, but always when I'm saying, it should be the amount that is always there in my bank account, right? So this is example of consistency plus partition tolerance, right? Trade-off is ensuring correctness but might deny requests when some nodes are unreachable. Moving on, so next is availability plus partition tolerance, but not consistency. For example, you take an example of social media platforms, right? Posts must be available even during network failures, right? Even if a network failure happens, I'm okay even if I'm seeing 1 hour old posts, right? Users may see slightly outdated that stale posts until synchronization happens. So the trade-off is system remains functional but may serve slightly outdated data. So this is an example of availability plus partition tolerance. The third one is about CA, consistency plus availability, but not partition tolerance. Scenarios: a centralized database always ensures all clients see the latest data like consistency and always responds availability, but it does not tolerate network partitions because it is not distributed. So as we discussed already, it's not a valid scenario for a distributed systems. Here trade-off is if the server fails, the whole system is down. Liking our content, go ahead and subscribe.